So, hello, just wanted to add this one because this is very important. Why can we get the Gauss's law using the continuous charge distribution that we had using Coulomb's law? Yes, we can approximate actually the approximation of Coulomb's law katong imuhang using the nasty integral. So you have E is equal to the integral of K dq over r squared tsaka yung Gauss's law na E dot n hat dA is equal to Q enclosed over epsilon sub naught. Okay, so recall na katong ato bitaw example nga we have here a point P tapos meron tayong line nga may length na A. Okay, the distance between this one is B. So recall that example, then meron tayong negative 1/2 A tsaka yung origin mo is exactly at the midpoint of your of the line. So recall that yung nakuha natin na expression using the Coulomb's law dito is we have equal to 2k lambda, so b a square root of a squared plus 4b squared. Okay, so we have that expression, di ba? So say j hat ito, di ba? So j hat, yeah. So so for a finite length, ito yung expression ng electric field niya. Okay? So, yun yung advantage ng Coulomb's law kahit hindi siya, wala siyang symmetry, enough symmetry for our charge distribution, we can actually use a charge distribution, this Coulomb's law with or without symmetry. Okay? So, here, yes, so if using the Gauss's law, so 'di ba yung charge yung line charge natin goes to infinity, 'di ba? So ito infinity tsaka goes infinity. So meaning kung ating i-compare ng atong kuan, so same gihapon nga B iyang distance sa imong field point P. So this means that when A, meaning the length of the line charge is very large than the distance of your field point to the line charge, then what will happen to the electric field expression? So in approximation, so we can actually get the electric field that we have just calculated before this video, diba? So we have E, so we can put the approximation symbol here, then 2k lambda over B A. Yeah, since A is greater than B squared, so therefore we can put lang si A squared kasi mas dako man si A squared kay ni B squared, di ba? So approximately this can be equal to 2k lambda over B, so we can cancel this out. Then the electric field is equal to, so 2 times 1 over 4 pi, which is the value of our k lambda over B, so we can cancel this, we can put this one as 2 pi epsilon sub naught B, which is the same expression as our electric field using the Gauss's law as lambda 2 pi epsilon sub naught R, diba? So as you can see here, where your R man is the distance from the line charge towards the field point, kasi yung field point natin is nasa located sa Gaussian surface, di ba, na cylinder. So actually located yung field point natin kasi on the surface, ito yung electric field na makukuha natin. So basically, same lang yung nakuha natin in approximation with the Coulomb's law. So how about yung charge sheet? So remember na yung charge sheet is, we have the expression for Gauss's law. So as you recall, diba? So E for Gauss's law, so nakuha natin sa Gauss's law sa charge sheet as sigma over 2 pi epsilon sub naught. So as you recall, one of the charge distribution that we have calculated in our Coulomb's law is a disk, a thin circular disk. So now if we extend the disk to infinity, we cannot distinguish if this is a disk ba or a rectangular disc or circular disc, whatever, because it is very large naman. We cannot distinguish na because of its very large na kaayo, it will extend to infinity. So recall na yung electric field lines nga natuhan natin sa Coulomb's law using this expression from a distance say P at L. So we have here, so as I recall, that is 2 pi k sigma. Then we have 1 minus, I think, L. So correct me if I'm wrong. Tapos then we have r squared plus L squared. And that is in the direction of I hat. So direction is not needed here, okay? So we just have to approximate if this approximation still, so if we let our discs very large, are this gonna, you know, coincide with our Gauss's law expression that we had for the large plate sheet, okay? So here, so when you increase the r to infinity, what will happen is r is greater than L, okay? So here in our expression, we have 2 pi k sigma, then we have 1 minus, so what you're going to do here is your r is greater than L, so therefore ang naalang niya is basically r na lang, di ba? R. But since your L over R, so can I put this in approximation? Since L divided by R, so when you divide both sides by R, this means that that is less than 2, 1. So therefore 1 is greater than the L over R, so we can neglect this one, okay? So therefore in approximation, we have 2 pi k sigma na lang, okay? Times 1 naman siya, di ba? So simply substituting k as your 1 over 4 pi epsilon sub naught, we have 1 over 4 pi epsilon sub naught, then we have sigma, sigma, then cancel, so ano binili lang kay 2, so this is sigma over 2 epsilon sub naught, which actually coincide, is this 2 pi with our 2, I think wala pi, so this actually coincide with our expression in our Gauss's law. So again, we can approximate man the result of the Gauss's law that we had sa Coulomb's law. Okay, so they're basically in unity and they are interconnected. So gayon lang, ang Gauss's law is only for symmetric properties, pero ang Coulomb's law can be used even though hindi symmetric ang distribution mo. Okay, so I think that's the point of this this video. And by the way, meron akong ikuan, okay? I will just this one. So this is not positive q, but kay since ang imuhang charge on the surface is negative q, kasi yung nakuha natin diba last time is negative q, so I will put negative q here. So basically yung yung electric field on the surface of the conductor, of the thin spherical conductor, is equal to q over 4 pi epsilon sub naught c squared. So c squared meaning yung radius niya is c, 'di ba? Sa outer kasi natin yung gagamitin. Okay, kaya we have this one expression. So the surface area of the sphere is actually equal to 4 pi r squared, or for our conductor that is c squared, okay, where the radius is c. So basically the electric field magnitude on the surface is equal to sigma over epsilon sub naught. Tsaka another point lang for the meron kasi ako nakalimutan, okay? So again, so if I have a field, diba? I have a spherical field nga may positive na excess charge, okay? So again, ngano ganing electric field is 0 because of the ano ganing ang imuhang charge must resides only on the surface, because one thing is electrostatic equilibrium. Okay, so kung makita nato diri ato ang surface, as you can see, the electric field is always perpendicular on the surface. Okay, which is our statement last time, di ba? Perpendicular siya. Why is nanumang dili perpendicular? So what will happen if the charge is not on the surface, meaning maka-ato siya sulod, maka-lagoy-ligoy siya. So what will happen is this. So I have a surface. Okay, suppose magkuha ako gamay nga surface. Then naa siya diri lang, wala siya sa surface. What will happen is the electric field will actually move the positive charge and this motion of your charge will actually disturb the electrostatic condition inside the conductor nga naman, because it will exert a force, okay, so which is equal to QE. Okay, so this force, for example yung electric field natin is padung paana. So maghatag ni siya og two components. So we have components along perpendicular tsaka parallel. So this parallel nga electric field component will actually make this charge move, thereby violating our electrostatic equilibrium na dapat atras la yung charge natin. Okay? So that is why yung electric field natin must be perpendicular tsaka walang tangential component or parallel component para yung ating charge resides entirely on the surface tsaka meron tayong sa electrostatic condition. Okay? So yun lang.